Hi guys, welcome to Nene Math. It's me, Nene, and today we are going to talk about the Pythagorean Theorem. So before we start our lesson, I'm going to have a quick recap of the right triangle because it is included in the Pythagorean Theorem. So I'm going to draw this triangle. So a right triangle is basically a triangle with a right angle which equals 90 degrees. And the Pythagorean theorem can be applied to help us find missing side lengths of this right triangle. And it's very helpful in geometry and trigonometry, which also involves triangles. So, for example, 6 and 7, we don't know this third side length, so we can use this theorem. So our formula for the Pythagorean theorem would be a squared plus b squared equals c squared. And I am going to label our side lengths for vocabulary, and the longest side length of our right triangle is going to be called our hypotenuse. It will be opposite of our right angle. And the other two side lengths that form our right angle is going to be called our legs. So now I'm going to label our variables to help define each leg. So the bottom leg is going to be A, our other leg will be B, and our hypotenuse will be C. These variables will always be fixed in our right triangle. You won't change these variables. For example, this leg, the bottom leg would be C. It's always going to be A. So let's move on to our first question. We are going to find the missing length X. So we have A and B. So all we have to do is plug those in to our formula. So our formula again is a squared plus b squared equals c squared. So now I'm just going to plug those in. So we have 9, that's going to be our a. So then we have 9 squared plus our b, which is 7, so that would be 7 squared. And then we would say that equals c squared since we don't know what our c is yet. So then we would break down the equation. We have 9 times 9 plus 7 times 7 equals c squared. So now we would just solve the exponents, and we would have 81 plus 49 equals c squared. So now I'm going to solve this problem in the corner. So I would have 81 plus 49. You would have 10, you'd carry the 1, and then you would have 13. So you would have 130 equals c squared. But that is not our final answer since we are looking for c, not c squared, so we would have to take the square root from both sides. But unfortunately, 130 is not a perfect square, so we're going to have to plug this into our calculator. So I'm going to take the square root of those two, and our answer is going to be 11.4 centimeters, and that equals C. So now let us move on to our next problem. Let's find the area of rectangle C. And we have our width already, we just need to find the length, and we can say area equals length times width for our rectangle. But to find this length, we need to solve the Pythagorean theorem to help us find the length. We already have our A and B, So we just need to find the c again. So the formula is a squared plus b squared equals c squared. So now what we have to do is just plug the numbers in the formula. So we have 8 squared plus b, that is our 6 squared. And we have that to equal c squared. And now we just break it up. We have 8 times 8 in parentheses plus 6 times 6 in parentheses. And that equals c squared. Now we are going to solve those. We have 64 plus 36 equals c squared. And now I'm going to solve that in the corner. We have 64 plus 36, and we have 10, carry the 1, and then we have 10. So then we would have 100. And we would have 100 equals c squared, and we need to find c, so we have to take our square roots from both sides. So then our answer would be 10 equals c squared. 10 equals c. But we are not done with our problem yet, since now we need to find the area of that rectangle. So all we have to do is just multiply area equals length times width. I'm going to write that formula on the bottom. And we just have to plug in the length times width, the length and the width. So we have 10 times 6, and that will give us 60 centimeters squared. So that will be our final answer for our last question. So guys, thank you for watching Nene Math, and stay tuned for more. Bye!